All right, so for the benefit of y'all watching at home, the mic just came on, so you missed the first 5 minutes of the lecture. But you saw what we were typing. Isn't that nice? What we're working on is functions. We've written 2 functions so far. This function is a named set of 4 statements that I can invoke with a single call. So down here, when I call go to -1, -100, it sends the turtle to that coordinate. And I can call that as many times as I want to just by using the word go to. So rather than copying and pasting that chunk of code, each time I want to go somewhere else, I just invoke the go to function. This one is supposed to draw a flower out of circles. Let's see if it actually works. I'm going to delete these 4 lines and just put something else here. Let's go to position 100, 0. And then let's draw a flower with 16 petals of size 100. And then let's go to -100, 0 and do the same thing. Flower with 16 petals, each one of radius 100. It's going very slowly, so I'm going to break it and I'm going to increase its speed. Up here, under t equals turtle, add t.speed parentheses 0. That removes all delay from it. Okay, so there we have our kind of spirograph thing going on. Rather than a mere 16 circles, let's draw 32 of them on each one. So I'm just going to go back and change the calls to flower to have 32 after them rather than 16. Yeah, that's pretty. Okay. So hopefully you can see the utility. If I wanted to draw 2 flowers in a row, without a function, I would have had to repeat this code twice. And it could be shortened by using a for loop rather than a while loop. We could shorten it a little bit. We might even be able to get it down to like 1 line, 2 lines at the most, but probably not. So that is the idea of functions. A set of, or a named, how did they word it? I like their definition. A named sequence of statements that performs a computation. A sequence of statements with a name. What can a function do? A function can have parameters. A function can return values. Now I can't really think of anything more to do with the turtles, so we're just going to kind of leave them there. We might want to cordon them off somehow with a by commenting out the go-to and the flower calls. Let's write a couple of math functions. Define molt x, y. And we're going to say result is equal, or just r, why not r? R is equal to x times y, return r. And then let's do divide, div, x, y. R is equal to x divided by y. Return y. We could even throw in a little check in there so that if they pass in a y, we don't generate an exception. Although it's not mathematically correct to say that something divided by 0 is 0, it's better than causing the program to crash, so I could put that as an if in there. I think I might. So if y no parentheses, if y is greater than 0, colon, and I'm going to shift that line. That was totally wrong. Why was I returning y here anyways?
If it's not.
Else r is equal to 0, and then return r. Like that.
Can you also do it with just two return statements?
Pardon me?
Can you just do it with two return statements?
I could put a return right here rather than calculating r first. You're right. I could make it like this. I'm going to rewrite this a little bit based on suggestion. If y is greater than 0, return x divided by y, and then underneath that I'm going to do return 0. Shortens it. And I could have done that up here. I could have just done return x times y. Now there's actually a reason that I follow this pattern of performing the calculation first and then returning it on the next one, because that allows a little bit of ease of debugging. If I wanted to, I could print out r before I returned it. Or if I was using an interactive debugger, I could check the value of r before it bails out of that function, which is harder to do if it's actually just return x divided by y. But either one works. All right, now let's print. Let's use those functions. Print mult 1020. Print division 1020. And since it's still got that import turtle stuff, every time we run it, it's going to pop open the turtle window rather than hiding our. We should probably have just started a new program. We're going to do that. Grab all of that define mult stuff. Cut. New file. Paste. Save as. I'm going to call it funky with a C rather than a K because we're playing with functions. Close the shell because it's getting cluttered. Run it again. There we go. It printed out 10 times 20, and it divided 10 by 20. So these illustrate that, a function can accept arguments. They're called arguments when you're passing them in. They're called parameters when you're using them inside here. What a parameter is it's just a variable that accepts a value from the argument set in, being passed in. So this is a variable, but it gets assigned the value of 10 when the function is invoked. This is a variable. It gets assigned the value 20 when the function is invoked. Now that's kind of a fine point. You don't necessarily add this to your code, but if you do something like this, say hi, name, and then you do print, I guess you could, hello, followed by the name, and then down here you say name is equal to Joe, and you do say hi, name. That looks real good to some people because this matches this. And then it upsets them if you do something like this. Person is equal to Joe. Say hi, person. This has almost nothing to do with this. The fact that they have different names is totally okay. The fact that they had same names a moment ago was purely a coincidence. This variable is not this variable. This variable just gets a copy of what's passed inside the function call. What gets passed inside the function call happens to be an expression that evaluates to the word Joe, which then fills in that variable, so when it runs, it prints hello name. But these are not the same. It just gets a copy of the value. In some languages, specifically C++ and C#, you could tie these things up together so that they really are the same variable. Meaning that if you did this, and it's not going to work, name is equal to Bob, and then you print out the person down here, print person, you might expect it to have changed that variable to Bob, but it will not have. It will still say Joe, because this is separate from this. It's declared separately. It gets a copy of the value. Once this function is done, then that value is lost. This is called a local variable. It's declared locally within the function. So there's no way to get it back out. No way to find out that name was assigned to Bob. If we wanted to pass Bob back, we would have to add a return statement. And then we could return Bob back and do something with it.
Professor,
Yes, sir.
would that work with a global variable named name?
Yes, you could put a global variable up there.
Would it still be okay with having say hi name if that's a floating variable?
It's still not going to change this one. Watch what's going to happen here. Let's do that. Name is equal to, I don't know. That's going to be our global variable, but we have to tell this function that it is a global variable. So I'm going to come in here and do global name. Then I'm going to run it, and the behavior is going to be exactly, oops.
Sorry.
Oh, name is the name of the parameter. Well, let's play with it and see if we can get it to work. I'm going to change this back to name. Do say hi name. Print out the name once it comes in. See if it prints out Bob. My expectation is that it's not going to. Let's find out. Yeah, print it out, JoJo. The way global variables work, I'm going to make one up here. Let's set a global variable called age equal to 0. Inside say hi, for some reason, I'm going to set the age equal to 10. And then after I've called say hi, I could print that age out and it would be 10. But for that to work, I'm going to have to add the word global to it. Right now, it'll still say 0. It stayed 0 because it thought that this age here was a local variable that was applicable only to here. So I can do global age, and now it knows that this age down here is actually one that's defined outside of the function. And so it runs and it prints out 10.
Wait. Why wouldn't it? Okay. I got it. Never mind.
Got it? Okay.
Yep.
I mean, it's kind of a weird point, so it's okay if you don't.
I got it. Yeah.
Okay.
Makes sense. You're setting with that global. You're setting it to override the age above it or anywhere else besides in another defined state.
Right. What it's saying is, I don't want age to be limited just to this function. I want you to use an age that was defined above me and to make changes to it.
Right.
So built-in functions. We've seen built-in functions before. Max and min. Give us the largest or give us the smaller. They work on both numbers and strings and pretty much anything else you can think of. So I could go to the shell here. I'm going to restart the shell, start a new one. The maximum of 10 and 20 is 20. The minimum of 10 and 20, if I don't make a mistake in typing it, is 10. The maximum of Joe and Zeke is Zeke. The minimum of, well, yeah, you know, of Joe and Zeke is Joe. So if you're comparing strings, alphabetically earlier ones are considered less than alphabetically later ones. And so you might wonder, probably not, what is greater, a $sign or an underscore? Let's find out. The underscore is greater. What's less, a backwards apostrophe or a forwards apostrophe? I guess the forwards apostrophe. Anyways. So anything that has some series of ordinal values behind it, anything that can be converted to something that can be compared against the other, can be used with min and max. Absolute value is another one, I believe. I hope we don't have to use math.abs, the math library, to get to it. Okay, yeah. So one textbook I used, maybe when you took it, I don't remember, called them BIFs. No, wait, you haven't taken scripting before. Anyways, built-in function, BIF. len, that returns the length of the string or the length of a list. We'll be using lists an awful lot. A list looks something like this. L is equal to, and I'm just doing all this in the shell. You put square braces around it and you type in some data separated by commas. 1, 2, 3, 4, 5, 10. That is a list that has 10 elements, 6 elements in it. So if I do len of L, it's going to be 6.
Will a list store more than one data type?
In this language, yes. Don't get in the habit of doing that because most languages the answer is an emphatic no. But Python's more flexible. Java, no. C++, C#. The only way you can do it in those languages is through some trickery involving inheritance and using a parent class in your list. You don't want to do that. Okay, so type conversion, we've already seen these. int pass into string 32 returns a 32. int of the word hello, whoops, it's an error. It'll round down, but it doesn't actually round down, it rounds closest to 0. So negative 2.3 becomes negative 2. 3.9 becomes 3. I wonder if the round function does the same thing. Let's find out. Round of negative 2.5. That becomes negative 2. Round of 2.5. That also becomes 2. How come that didn't round up? Round of 2.6. 3. Round of 2.6 is 3. How about round of negative 2.6? Negative 3. Okay. Random numbers. Random numbers are fun because we can make games, guessing games, or anything where, where you don't want things to just follow a pre-programmed pattern. Pac-Man, the ghosts always follow the exact same pattern. And you could develop, your own pattern to counteract their movements, and you could play forever as long as you could execute up until the kill screen. Once you hit level 256, the game was over. Ms. Pac-Man introduced random motions so that some of the ghosts followed random patterns to make it impossible for people just to memorize a certain sequence of moves. So, pardon?
There's your trivia for the day.
Yeah. So to use a random number generator, you use random, and there's more than one way of doing it, but it will generate a number starting at 0, going up to but not including 1. But there's a more useful one in my opinion, which is randint. I like that one because it gives you whole numbers. If I'm playing Yahtzee, I don't want that to be one of my die rolls and that to be my second one. So, you could convert these to integers via, some mathematical hackery, but it's far nicer to be able to do that. It still works like this. The low number is 5, and the highest, which it will reach. And this is one of the few functions where the upper bound is inclusive. So it will generate a number between 5 and 10 inclusive. So going back to our shell, random dot, why am I looking up there? It's covered up just like it is on my screen back here. Random int, a number between 100 and 200. And it blew up because I haven't had the import.
Right.
Import random. And then or even better, no, forget it. Yeah, from random, import randint. Give that a shot. Now we can type randint, if you spell it right, 1,5, and there we go. This syntax here is kind of cool because if you use import random, you still have to preface the functions with the word random in order to get them to work. But if you use this syntax, from this library, give me this function, You don't have to preface it with the word random. Might still work. Let's give it a shot. Random dot randint between 1 and 10 works, but you don't have to. Random int between negative 100 and positive 100. So let's write a program that will roll 3 d6, 6-sided dice,
Yes.
100 times in a row and calculate the average of them, which is not a real mystery, but let's do that. So let's go back to funky, and we'll just tack it onto funky. We're going to declare a variable called numRolls. For n in range numRolls, what that does is it says go through a sequence of numbers, a range of numbers starting at 0 and going up to but not including numRolls. So it actually is 100 numbers. It's just n will equal 0 through 99. We need an import. So above that import, let's do from random import RNDINT. And we're going to need a sum so that we can divide by the number of total rolls. I can't use my favorite word, which is sum, so I'm going to use total. Total is equal to 0. Let's define a function which will add up those 3 random numbers and return them as a value. This is really sloppy coding because I'm mixing functions right inside my code. But underneath that import statement, let's do that. Define roll6 and we're going to have n meaning the number of dice that we're rolling. Total is equal to 0. For x in range of up to n, I just needed a counter variable, so I'm still using single letter variable names, which are not ideal. Total plus equals random int between 1 and 6. And then after that, let's return the total. It is actually inclusive. You know, every other function in Python, the upper bounds is exclusive. In this case, it's not. Be warned that if you go to Java and use a random function, it is exclusive on the upper end. So you just have to look at the documentation to figure out whether it's not. Alrighty, so let's do it down here. Total is equal to 0. For n is equal to range numRolls. Total plus equals roll 6, but we're going to roll 3 6-siders. Would have been nice if we printed that number out. Let's do that. Let's get rid of that total plus equals. Let's change this line a little bit so that we say roll is equal to roll 6, something like that, and then we could print out the roll just so we can watch these numbers. And then let's add that onto the total. Total plus equals roll. Now at the bottom, let's print out the total, and let's print out the total divided by n, which was the total number of rolls. Except it's not called n, it's called numRolls, excuse me. So total, comma, total divided by numRolls. Alrighty. So the average rolling 100 times, adding 3 dice together, was 10.6. Let's change that to 1,000. If we commented out the print statement, it would run so much faster. So I'm going to do that. This print statement here inside my for loop, I'm commenting it out. And there we go, 10.511. That's what we would expect The average of of 3 dice, of one die, you have these values, 1, 2, 3, 4, 5, 6. So if you rolled one die over and over and over, added them all up, and then divided by the number of rolls, the average should be somewhere between these two, so it should be 3.5. So since we're rolling 3 dice, it's 3 times 3.5, which is about 10.511. The larger we make this number, the closer to exactly 3.5 it should be. I'm going to change this to 100,000. Run it again, and since I'm not printing, it still ought to go lickety-split. 10.488, I'm not sure if that's much closer to 3.5 than it was before. Is it generating the same numbers each time? 10.500, well that's pretty close to 10.5, honestly. Okay, so we've written another function. Let me get this window out of the way. What did this function do? It used the random function to roll some random numbers between the limits that we specified, add them all up and return them. Why did we do that? So that when we wanted to roll 3 random numbers, we could do it like that.
I'm having a syntax error on my end for some odd reason.
Let me come look.
For the in range, I'm having a syntax error.
Okay. Make it 4. It's
Oh,
good from.
I didn't even see that. I put
Yeah.
from. Why did I do that? I didn't know
I
from
may
was
have said the word from. Yeah, wait a minute. There's something wrong. What's that say? Okay, so above the for statement, put total is equal to 0. I use the same variable name in 2 different places, which is slightly confusing. So got an average of 10.49. Cool. Alrighty guys, so if you were going to make a game that where your character had a strength and an intelligence and a dexterity, do something like this. We already have our roll function, right? It looks like that. Strength is equal to roll 6. This one's stronger than most character. He gets 4 dice. Now STR actually means string, so I should not be using
I ran into that problem when I was making my program.
there. So capital STR.
Intelligence also.
And then capital INT for intelligence.
Right.
Now my character is a barbarian. He only gets 2 dice worth of intelligence. And dexterity is equal to roll 6, 3 dice. Now let's print those stats out. Print strength, colon, comma, STR. Print int, colon, comma, INT. Print dex, comma, DEX. And I had my number of rolls set to 100,000. I'm lowering that a little bit so it won't pause every time I run the program. All right, let's do that again. Now you could make a program that would, if for your favorite system, roll these numbers over and over and over until they meet some certain criteria. Like you could say, okay, I'm not going to let you stop rolling until
Your average is.
yeah, your average is 17. Something stupid like that. Let's do that for total giggles. Okay, except we're not going to make it 17. That might take a long time. Okay, so inside, do this. We're going to want to indent these 6 lines of code because we're going to stick it in a while loop. Do that. Okay. Now let's initialize a variable called AVG and set it equal to 0. Now it should not be 0. That'd be bad. Yeah, that'll work. And while average is less than 16, change all these 4s and 2s to 3s just because that's the way we were born and raised. Okay. And then down here, let's do average is equal to, and we need to add those three things up and divide them by 3. So I do need a colon here. Thank you. I would have gotten a syntax error if I had not put a colon on the while statement. So underneath the print statements, let's do average is equal to, and I'm going to put in parentheses, str plus int plus dex, and then outside of the parentheses divided by 3. And then I'm going to just put up the word print done at the bottom so that we have some indication of that that's the end of our code. All right, this could take a long time. I shouldn't be printing it until it actually gets the result.
Right.
So take those 3 lines of code, the print statement, cut them, paste them. You can get rid of that done then. And unindent them, dedent them. All right. Okay, hey Dungeon Master, I got my character ready. I had to roll for quite a while.
Oh, shoot. Mine's still at it.
Let's see how many rolls it would take to get straight 18s.
Oh.
So we need a counter.
Mine's still at it.
So up here above the while statement, do counters. I know I'm going fast and I'm adding stuff in the wrong places, and so this is going to be a little hard to follow. But add that line, counter is equal to 0. Underneath the while line, add counter plus equals 1. And then down here at the bottom, print the counter out as well. And I'm putting semicolons in where they don't need to be. Okay, it took 383 iterations to get somebody with an average above 16. What if I make this average is less than 18? How many rolls is that going to take? How many times of characters are we going to have to roll in Scratch? It's still working on it. Apparently that's too hard for it. Let's make it 17. All right, it took 44,000 rolls. That time it only took 2,800 rolls.
So how would you take the minimum of the 4 rolls and then delete the 4th?
You do dice 1, 2, 3, 4, add them together,
Right.
make a dice 5 with equaling the minimum of dice 1, 2, 3, and 4, and then you minus that.
Yeah, you could do that. You could subtract the minimum of your roll. So if you're trying to roll 4 dice and pick the 3 highest, let's do that. Nah. Let's define a new function to do that. Define top 3 of 4. Colon.
How about THACO?
Yeah, Thaco, right.
Oh, stop it.
Okay,
No.
we're geeking out for y'all who haven't played Dungeons and Dragons or Pathfinder. Okay, so D1 is equal to random int between 1 and 6. D2 is equal to random int 1 and 6. D3 is equal to random int 1 of 6. D4 is equal to random int 1 of 6. Now there's several ways we could approach this. We could stuff them all in a list and then lose the last item in the list, or we can just do it mathematically as you were suggesting, in which case the total is equal to D1 plus D2 plus D3 plus D4 minus the minimum of D1, D2, D3, and D4.
I've been working on this all weekend.
So if we use this function to generate our high rolling numbers rather than the other one, then it would take a lot fewer rolls. Let's test it out though. A is equal to top 3 of 4. Tell you what, let's do that averaging thing again. What did I call the code up here? Num rolls. Okay, so total is equal to 0. Num rolls is equal to 100. We're going to roll them 100 times, or 1,000. Doesn't take very long to do. For x in range, num rolls, colon, total plus equals top 3 of 4. And then we want to print total and total divided by num rolls. That ought to be higher than our earlier average was. And I'm going to stick the word average, quote, comma, in front of that, just because this stuff's getting cluttered. So earlier our average, where we were rolling 3 dice, the average of 3 dice is about 10.5. The average of 4 dice, take the top 3, is 12.3, more or less. You know, and we can increase this number to get a more accurate average. 12.24. If you wanted to take the top 5 out of 3, that I would throw them into a list and chop the last 2 items off the list. Put them in a list, sort the list, lose the last 2 items, and then sum the list. All right. So we're having way more fun doing functions than I've done in any other class. This has been fun. Some of y'all are going, this isn't fun at all. But some of us are enjoying it, I promise. Let's see. Now here's something I hadn't seen before until I read this text. Is a method of the random class called .choice, where you pass it a list and it'll pick one randomly. So go to your shell, run Python shell, and do books, just capital B, is equal to, and then let's put some books in there. Dictionary, JAWS, math book. Okay, this is dumb, but now we're done. And now we're going to do import random. And we want a random.choice from that list of books. Each time we type random.choice, we may get another one. I mean, we'll only have 3 choices, so that's not real impressive. But I'd like for it not to do the same one every time, so I'm going to keep type. Okay, there we go. I got a different value. So that's kind of cool. That only saves you a little bit. If we didn't have that function, what we would have to do is get the length of the list and generate a random number between 0 and the length of the list minus 1. And that would do the same thing. But it's cool for it to have that ability. The random module also provides functions to generate random values from continuous distributions, including Gaussian, exponential, gamma, and a few more. Now, that just flew about 4 times over my head. But good to know that it's there. Math functions. We've kind of seen the math functions, right? At least Actually, I don't recall if we did or not. I know that we know that there's math.py, and there are logarithm functions and sine functions and stuff like that. If you're dealing with the geometry functions, be aware that you have to convert degrees to radians for them to work. That bit me one day just because I was tearing my hair out wondering why it wasn't working. And then, oh yeah, you have to convert them to radians. If you don't remember your geometry, well, I'm probably not going to give you any problems that require that. So math.py is accurate to about 15 digits. Adding new functions, here's how we did it. Define print lyrics, parentheses in parentheses. And you always start off your definitions with DEF. You always end them with parentheses. If you have anything between the parentheses, you can put a list of variables called parameters separated by commas, or you can just put nothing there, followed by a comma, and then you print out, then you do whatever that function is supposed to do whenever it's invoked. And following the theme of Monty Python, I'm a lumberjack, I'm okay, I sleep all night, and I work all day. So let's see. I'm a lumberjack, I'm okay, I sleep all night and I work all day. I'm a lumberjack and I'm okay, I sleep all night and I work all day. Why did it do that 2 times in a row? Looking at this code. We have a function called repeat lyrics, which gets invoked here, and it prints the lyrics twice. So how do you know what's going to get run first? And hint, it's not the first thing in the program. Yeah, it's the first one that's not indented, the first one that's not a defined statement. If we did that thing where we did the if underscore underscore name equals underscore underscore main, you know, we could invoke our code from there. Here, that's the first line that actually executes. By the time we get here, the rest of these functions have been defined. This would not work as well if the order of this, when I say as well, I mean at all, if the order of these were reversed. If I copy this stuff and I paste it into my script, like this, but I call repeat lyrics before the functions are defined, that's an error. It says repeat lyrics not defined. And you go, oh, yeah, it is. No, it's not defined until after. Now, not all languages act like this. C and C++ do. You have to have the function defined before you can invoke it. Java and C# do not. You can define the functions in any order that you want. The way you get around that is by doing that thing with main down here at the bottom, so that all your functions get imported before any code runs. That just kind of forces the issue. And then the order in which the functions are defined does not matter. Here's another example. I think to myself, okay, I'm going to put repeat lyrics down there, but say that I had brought them in like this. No, that's not going to work. This is a bad example. There we go. Really bad example. What am I doing? Pay no attention to the clumsy cutting and pasting. Okay. What is wrong with this code?
Oh, you have repeat. Alright, now.
It uses print lyrics before it's defined.
Right, print lyrics has never been defined. Which is okay if they're all being defined before any of the code is being executed. So this is okay. It's okay to call repeat lyrics, which calls print lyrics, even though these are defined above that one, because by the time you get here, all of the definitions have been set. Flow of execution. I think it's kind of implied by what we've been talking about, but when the flow of execution happens, the first thing it runs is the first non-indented code. Then it jumps up here. it executes that line, which causes it to jump here, which causes it to execute this line. Now print in itself is a function, but we don't get to see the source code. So it runs over here inside Python, it executes a print, and it comes back, and then it executes the next line. Same thing. We invoke another print statement, so it runs in and does some secret code, and it comes back, and now we're done. And even though there's no return word there, the fact that the indentation stops functions as a return, so it returns. And when it returns, it comes back to here because that's where it was. It did just execute this line. Now it's ready to execute this line. So it invokes that, and it comes and it does these two things again. It hits the end of the indented code. It returns again. Now we are here. There's no more indented code, so it returns, and now we're done with that. I think that actually made it sound more complicated. I know yet you've already got the idea. Define a colon print who, define B colon, which calls A, define C colon, which calls B, and then let's call C down here. That's really stupid. Let's add some print statements to it. After the call to A, let's print what, and then after the call to B, let's print why, because that's how we're feeling about the class right now. Why? Okay, here we go. Now when we run it, we could work through in the order in which these things are going to happen. What is it going to print? Well, we call C. It goes here. It invokes B. B jumps up here. It invokes A. It prints who. It returns. It prints what. It returns. And it prints why. Now, just because I did it in that order, it's going who, what, and why. But if I reverse the order, if I put A underneath C, it still would say who, what, and why. Because the important thing is not the order in which they're defined, but the order in which they're invoking each other. So I'm going to prove that. I'm going to put that down there, and hopefully it will say who, what, and why. Yeah. So function calls are one way of controlling the order of execution. Execution is always top-down. Well, not always. Function calls can send it somewhere else, and then loops can cause code to repeat. And if you have if statements, then you wind up skipping sections of code. I think we are about talked out, speaking in the royal we. Fruitful functions. A fruitful function is one that returns a value. None of these return values, and I know that half of y'all have already heard the term fruitful function. None of these return values, so they are known as void functions. In some languages, if a function is void, you actually have to use that keyword. You put the word void in front of it. Not this one. A fruitful function is one that returns a value. We've been writing fruitful functions all through this code. There's a fruitful function because it returned a value. In some languages, you have to define what it can return. You have to put the word like int up here. You're warning the language, oh, by the way, my function returns an int. And it's an error if it doesn't. But Python doesn't do that. So that's the difference between a fruitful function and a void function. I'm just going to put a little comment down here. Fruitful functions versus void functions. Fruitful return values. Void don't. How about that for bad English? All right, we're done. Let's create a Dropbox and close down for the day.